Morning everybody. Now here's a CPU board right here. Here's the processor. It's 40-pin dual inline package. Its part number is R65C02P2. It's a 6502 made by Rockwell. Over here some versatile interface adapters. Their part number is G65SC22P-2. Here's the RAM. There's 4 pieces of RAM here, made by RCA. Their part number CDM6116AE3. Here's 2 EPROMs, and their part numbers are NMC27C64Q-25. Now, what we're going to do, just for the fun of it, we're going to determine where these 2 EPROMs are on the address bus. In other words, what address is this EPROM at, and what address is this EPROM at? I'm going to do a little bit of drawing of the circuit to determine those addresses. It's going to be a lot of fun here. I've got the data sheet for the 6502. Over here is a 74HCT138. Here's a 74HCT139, and here's another 74HCT138. The 74HCT138 is a 3-line to 8-line decoder demultiplexer. The 74139 is a dual 2-line to 4-line decoder demultiplexer. And whenever you see those part numbers of ICs, 9 times out of 10 they're used in the addressing scheme of a CPU board there. Okay, let me move the camera and we'll map the chip enables and the output enables of these 2 EPROMs. Work this one out first, and then secondly we'll work this one out here. Move everything over a little bit so I can get in the camera. First thing we want to do is draw our EPROM addresses. There we go. This is NMC27C64 Q-25. Let's see how many address lines it has. The highest address is on pin 2, A12, and the lowest address is A0, that's on pin 10, so let's draw that in there. A12, A11, A10, A9, A8, A7, A6, A5, A4, A3, A2, A1, and A0. And we'll draw that right here. A12, A11, A10, A9, A8, address 7, A6, A5, A4, A3, A2, A1, and A0. Let's write the pin numbers in. A12 is on pin 2. There's A7 on pin 3. A6 on 4, A5 on pin 5, A4 on pin 6, A3 on pin 7, A2 is on pin 8, A9 or A1 is on pin 9, and A10 getting mixed up here, getting senile in my old age. A0 is on pin 10. Let's go find A11. A11 is on 23, and there's A9 on 24. A8 is on 25. Where's A10 at? A10 down here on 21, pin 21. Okay, now this is the address bus, and the address bus is going to be common from the EPROMs, the SRAM, and the VIAs, and they're all going to be connected to the 6502. So let's go to pin 2, that's A12. Let's pull up the data sheet on the 6502. I'll set this over here on the left side. It says A12 is on pin 22 of the 6502. I got my meter set in beep mode. It's off the screen, but you'll be able to hear it. Here's pin 2. Going to pin 22. Okay, let's see if it's over here too. Nope. A12 is not part of the SRAM. Okay, so that is 22. A11 is on pin 20 of the 6502, and our A11 is on 23. 15, 16, 17, 18, 19, 20, 21, 22, 23. Yes, it is. So here's 20. A10 is 19. A9 is 18, 17, 16, 15, 14, 13, 12, 11. A1 is on 10, and A9, or A0 is on 9, okay? So, let's go to 19, A10 is on 21, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Went too far? Yeah, I did. Okay. 16, 17, 18, 19, 20, 21. Yes, it goes to 19 on the 6502. Let me bring that into the screen here where you can see that 6502 that I'm getting on. Okay, so far we got A12, A11, and A18. I'm showing just one wire between the 27C64 and the 6502. Processor, but these lines go to multiple places on the board. They go to the SRAM and the VIAs. So we're at A9 now. A9 is on pin 18 of the processor over here. That should go to 24. There we are. 8, 7, 6, 5, 4. Yes, it does. 18. 25. Let's see. 25 is address 8, and that goes to 17. 20, 19, 18, 17. Should go to 25. 16, 17, 18, 5. Yes, it does. 17. And A7 right now, that goes to pin 16. Pin 3 right here, 20, 19, 18, 17, 16. Yes, the next one. A6, A5, A4, A3, A2, A1, and A0. Yes. Okay. So this is 16, 15, 14, 13, pin 12, pin 11, pin 10, and pin 9 on the 6502. Connect all those right there. R65CO2 P2. Let's write that in there. All right. Now on the EPROMs, you're going to have a chip enable. Here on our EPROM, it's on pin 20, and you're going to have an output enable on pin 22. So let's write those in there. We'll see where they go to. Pin 20, C, E bar, pin 22 is output enable bar. Okay, let's see if any of those are tied directly to ground so that they're enabled all the time. Go to our ground pin. 14, there's 15, 16, 17, 18, 19, 20. Nope. Nope, not connected. 15, 16, 17, 18, 19, 20, 21, 22. Alright, 22 on both EPROMs is always tied to ground. The output enable is always made. Now let's find out where pin 20 chip enable of that EPROM goes to. Okay, we get on pin 20, 15, 16, 17, 18, 19, 20. And let's just run down these pins right here with the other probe until it beeps. Oh, there it is. Let's see if it goes over here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the CD74 ACT139. It goes to pin 10. CD74 HCT 139E. Okay, now let's see, that was this EPROM. Let's see if the second EPROM goes to that same IC. It's 15, 16, 17, 18, 19, 20. That's the chip enable. Let's see here. Oh yeah, it goes to pin 9. So let's draw that in there. Alright, here's what we got so far. The chip enables of both EPROMs go to the CD74 HCT139E. let's go pull up the data sheet on that, and we'll finish drawing that out. So pin 10 is 2Y2, that's an output. Pin 9 is 2Y3, that's an output. The inputs are 2B, that's on pin 13, and 2A, that's on pin 14, and pin 15 is an enable, that's 2G bar. Now, we'll find out what these inputs are doing. Let's see here. Bring this over just a little bit so we're back in the screen, covering up our drawing, but right here, this is all we're worried about is these three inputs at the moment. Let's put the meter back in beat mode. Now we're going to look and see if that enable is always asserted to ground. That's pin 15. Yes, it is. Okay. Let's tie that to ground. Now let's see where pin 13 goes to. It says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see if it goes over to the processor. Yes, it does. There it is. On pin 21, 22, 23, pin 24. Nope. 9, 10, 11, 12, 13. Goes to 24. Let's see where 14 goes to. 14 goes to 23 of the microprocessor. Let's draw that in there. That is R65CO2P2. Okay, let's pull up the data sheet and set the board off to the side there. Let's pull up the data sheet and find out what pins 23 and 24 are. Okay, 23 is address 13. 24 is address 14. Okay, we know that the chip enables on these two EPROMs must go low because it has the bar over it, chip enable bar, the bar indicating that it's active low. So this output right here must go low to enable this IC, chip enable it, and this output on pin 9 going to pin 20 must be low to activate the other EPROM. Write that in there. Okay. So what must the inputs do to make this go active low? First thing we need to do is draw out a little bit of truth tabling, and I think we got enough room up here to do it. Let's see. I think we could do it up here. Okay, we'll put A15 right there, A14 next, A13, A12, 10, a 9, a 8, a 7, a 6, a 5, a 4, a 3, a 2, a 1, and a 0. I'm going to go get a ruler because I want to make some straight lines down here so we can fill in our data. I'll be back in just a minute. Okay, I'm back. Let's make us some lines down here. Okay, we're going to call this IC U1. We'll call this one U2. So here's going to be the starting address for U1, the ending address for U1. Here's going to be the starting address for U2, and here's going to be the ending address for U2. Now from the truth table of the 74HCT139 right here, for 2Y2 pin 10 to go low, let's take a look at it. Here's Y2. For it to go low, B needs to be high and A needs to be low. Okay, B is 14. That needs to be high. And A, which is on pin 14 there, A13 needs to be low. Okay. Now this one here is a don't care. We'll put an X right there. Let's see. You know what? Let's separate the nibbles. It'll be easier to see. There's 4 bits right there. 1, 2, 3, 4. There's 4 bits right there. 1, 2, 3, 4. There's 4 bits right there, and then 4 bits right here. Okay, put a 0 right there. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That's our starting address for this EPROM right here. This is a binary 4. So we'll put 4 right here. This is the starting address. Then 0, 0, 0. So our starting address is at hexadecimal 4000. The ending address, let's put an X right here. Let's go ahead and X that. These are don't cares. Our ending address would be 1, 1, 1, 1, all ones. And this is a binary 5, 0, 1, 0, 1. So our address, ending address would be 5. That's hexadecimal F, hexadecimal F, and hexadecimal F. So here's the start of U1, and here's the ending address of U1 right there. Now let's do U2. What makes the chip enable on U2 go low? It's connected to the CD74HCT139E on pin 9. Let's move this up a little bit right here so you can see it. What makes pin 9 go low to activate that chip enable on that EPROM right there? That's 2Y3 on pin 9 here's Y3. For Y3 to go low, B and A inputs have to both be high. So here's A14, which is the B input, or that needs to be high. And here's A13, which is the A input, pin 14 there, that has to be high. So both these have to be high. The starting address, let's see where that's at. Let's fill in our zeros again. All zeros. We called this one U1. Here we'll do U2. Okay, this is hexadecimal 6 and all zeros. So the starting address is at 6000 hexadecimal. The ending address, fill in all these ones, and that is a binary 7, a hexadecimal 7. All ones is 1111 is hexadecimal F, hexadecimal F, hexadecimal F. So there is the starting and ending address of the second EPROM. And you want to see something that's interesting? Let me bring this up close to you. On the labels of the EPROMs, see if I can get this in there where you can see it. Right there's address 4000, and here's address 6000. It's written on the label. Isn't that amazing? And we worked it out the long way. But you know, sometimes they'll put the checksum in hexadecimal on the label, so that could have been a checksum, but no, it was the address. I put all this up at the end of the video along with the data sheets so you can do this for yourself if you ever had to. That's a lot of fun. That's a lot of fun doing stuff like that. All right, everyone. We'll see you next time.